This is Coding Back, Java, Logic 1, Caught Speeding. You are driving a little too fast, and a police officer stops you. Write code to compute the result, encoded as an int value. 0 equals no ticket, 1 equals small ticket, and 2 equals big ticket. If speed is 60 or less, the result is 0. If speed is between 61 and 80 inclusive, the result is 1. If speed is 81 or more, the result is 2. Unless it's your birthday. On that day, your speed can be 5 higher in all cases. So looking at what we need to do, we can either return a 0, a 1, or a 2. If our speed is 60 or less, that's going to be inclusive because we point out if it is 60 or less, so less than or equal to 60, then we're not going to get a ticket. We'll return 0. If it's 61 up to 80 inclusive, then it's going to be 1. It's going to be a small ticket. But if it's greater than 80, so 81 or more, the result is 2, a large ticket. Unless it's our birthday, we get to be 5 greater in all cases. So let's start by taking a look at the birthday. We can write it out like this. We can say if it is our birthday, right? Is birthday is Boolean, so we can put that inside of the parentheses of our if statement because an if statement takes a Boolean value or expression, anything that evaluates to true or false. So if it is our birthday, then we can go ahead, and run all of the scenarios with the 5 extra miles per hour. So if speed is less than or equal to 65, then we're going to return a 0. Now, I'm starting with the smaller one first and then working my way up. The reason for that is because if it's not less than 65, if speed is not less than or equal to 65, then I know it's greater than it, right? Because if it were less than 65, this would be true. So if this is false, that means I know for a fact that speed is greater than 65. So in my next else if statement, I don't have to put if speed is greater than 65. I already know that if I get to this point in my code, it will be greater than 65. So I can just put the second part, which is if it's less than 85. So if it's less than 85, we'll go ahead and return a 1. Now, let's look at this. If the speed is 60, is the speed less than or equal to 65? Yes, it is. It's also less than or equal to 85. So how does this not get evaluated? That's because if the speed is less than or equal to 65, this code block right here will be evaluated and will return 0, and this will never get ran at all. On top of that, in an if-else-if statement, if the first Boolean expression is true, then this expression never gets evaluated, meaning this code can never run. That's why we're safe to start with the lower number first and then move up to the next number without having to repeat greater than 65. So if it's not less than or equal to 85, at this point in our code, we know that it has to be greater than 85, which means we can go ahead and just return 2 because we know it's greater than 85. Now here we're to the end of our if is birthday block, so we can come out of this and we can go ahead and write the conditions for if it's not our birthday in the exact same manner. If speed is less than or equal to 60, then we can go ahead and return 0. We're not going to get a ticket. Else if parentheses, if speed is less than or equal to 80, we're going to get a small ticket, so return 1. And then at the end of it, if none of these have happened, we can just go ahead and return 2 because we know it's not our birthday. We know we're not going less than 60, we're not going less than 80. We're going to go ahead and just return 2. It's a big ticket. So if we run that, we can see that everything's correct. It passed all the tests. Now if we look at this, we can see that we're kind of repeating ourselves here. This bit of logic and this bit of logic are almost identical except for the numbers on the range. So let's see if we can refactor this and make it a little easier to read and use less lines of code. So let's go ahead and think about it logically like this. We know what our speeds are. The speeds are below 60 and below 80, and then anything above it is a 2, right? Unless it's our birthday, those speeds are 5 more. So what if we can take and create a variable that takes a look and says, if it's our birthday, we're going to add 5 to everything. If it's not our birthday, we're not going to add. We're going to add 0 to everything and keep those initial speeds. So what we can do here is we can create an integer. So int, we'll call this additional. So if it is our birthday, then we're going to get 5 extra miles per hour of leeway. We're going to set this equal to is birthday. So this is Boolean. What we're using here is going to be a ternary operator. So you put a question mark here, 5:0. The way a ternary operator works is you have a Boolean expression right here, either a value or an expression, anything that evaluates to true or false. And then this question mark is basically saying, if this is true, whatever follows the question mark is what will result. This colon is like saying else, this will result. So this question mark and this colon are basically like an if statement and an else statement. So instead of writing out an if else, we can condense it all into one line. So additional will equal either 5 or 0 depending on whether is birthday is true. If it's true, it'll be 5. If it's false, additional will equal 0. Then we can take and basically write the same code we did before and say if the speed is less than or equal to 60 plus additional, right? So since if it's my birthday, additional will be 5, it will automatically raise this to 65. If it's not my birthday, it'll be 0, leaving this at 60. Then we can go ahead and return 0. Else, if the speed is less than or equal to 80 plus additional, then we can return 1, and then otherwise we can return 2. So let's run this and see, not a statement, line 5. Oh, sorry, else if, run that, there we go, they all pass. So we reduced this by almost half of the lines by adding this extra piece of logic here. So that's how when you have problems like this and you start seeing that you're repeating code, try to think of a more creative way that you can use a variable or something else to condense that and logically deduce what the answer should be.